hope you're doing great, because I'm really happy to be here, and it's so nice, because I'm even happier to make it on time, because picture this, like 2 months ago, I was so excited for my Euruko talk, and I just ran to the Portuguese embassy and applied for my visa, and it was like, that was the best day of the past year. But moving fast forward to 4 days ago, like 24 hours before my flight, and I didn't have my passport, and I didn't even know if my visa was approved. That sucked. But as you can see, I'm here, and with my new passport, new and shiny Ruby passport, no country will be able to resist me. Yeah. So, thanks. And you know, with all this journey, it really felt like I came from Mars. And you know, I came here with a simple question. Have you ever seen this code in your test suite? And I bet you have. Like, don't be shy. Just, yeah, I see you. Yeah, you have seen this. And you all know how it works. You write a test, run it locally, it's green, everything is perfect. Then you push it to CI and boom. Suddenly it's playing roulette. Sometimes it passes, sometimes it doesn't. You just created like a little flaky monster. And at first you try to adjust, to do a little trick. Let's adjust this value a bit. And then again, just to find this sweet magical spot when your tests don't fail every other time and your whole test suite time doesn't launch into orbit. And then comes the next part, just smashing that button. You know that, yeah, especially before you need to push this like super critical must to go prod to prod right now feature. Yeah, we've all been there. But at some point you just get fed up and you just comment it out because it stays in your way. And yeah, sounds familiar. We've all been here, we've all done that. And you know, it gets 10 times worse once threads enter the picture. And that's exactly what I had to face while working on the Ruby client for nuts. Have anyone worked with nuts before? Yeah, great, yeah. So for those who doesn't know or haven't used, nuts is a distributed messaging system. It's written in Go, and it has a lot of clients for many languages, and Ruby included. And you know, naturally, there are a lot of threads inside of it. So this is the thing that I saw like multiple times while I worked on it. And at some point, I found myself asking, is there a better way to do this? Is there a better way to test this kind of code? And so let's find out. So let's go back to that infamous test and look at the code itself. And oh boy, what we have here, we have a thread, we have an infinite loop, and we have some logic just packed inside it. But if you look closely at that piece of code, like most of the logic actually squeezed into these six lines of code. So maybe we can try to move it out to a different place, for example, to a method. Suddenly, we have no threads, we have no loops, just plain Ruby code that we can test in a nice, like, single-threaded environment. And even better, we can use that previous test. We just remove sleep, and everything works. Everything passes, because there are no threads. Nothing interferes with this test. And this trick I like to call divide and conquer. Actually, I like to call a lot of things divide and conquer. So divide is separate your core logic from the threads as much as you can, and then test them in isolation in a single-threaded environment. And you know, the best part is this little trick takes care of about like 80% and sometimes even more of your testing needs. But here's the question, what's about the other 20%? Well, the other 20% is all about dealing with threats themselves. So this is exactly what we are going to do right now. So let's go back again. Here is our method after we moved all the core logic outside. And at this point, what we want to test is not whether the connection checks works, because we already did that. We want to test that the checks runs continuously, because it's a loop. But to do that, we need to know when the check condition method run at least once, or maybe like multiple times. What we can do here? Well, we can put sleep in it. Actually, I could have used like a little bit sleep today, but it's not a good thing here, and maybe there is another way. And yeah, it is. There is. Ruby actually has like a mechanism for this called condition variables. So what it is, condition variables lets one thread signal another thread that it's done doing something. And here how it works. So you create a condition variable alongside a mutex. Then you pass that condition variable into a thread you want to wait for. And when the thread is done, it signals the condition. And meanwhile, your initiating thread, like, okay, your main thread is asleep, waiting to be woken up when all things is done. Sounds neat, right? Well, let's be honest. It doesn't look good. It has a lot of lines of code, and nobody wants to copy-paste it into every little test that you have. But here, where concurrent Ruby comes into play. And like, I hope a lot of people have heard about concurrent Ruby. So concurrent Ruby is a concurrency toolkit for Ruby inspired by classic concurrency patterns and patterns from other languages. And it comes with countdown latch, which actually kind of does the thing that we want, and we implement it with condition variables, but it looks better. It takes way fewer lines of code. And even better, you can define how many times or threads you want to wait for by setting a count. So each countdown call decreases this number one by one, and when it reaches 0, your initiating thread wakes up. So looks nice. Doesn't take a lot of lines of code. So the last thing that we want to do, we need to hook it up to this check condition. And we actually don't want to touch the original code, because like, we are testing it. We don't want to change it for testing purposes. And it wouldn't be Ruby if we couldn't do it. So we can use a little bit of metaprogramming magic. And in the test, we can simply redefine our methods and to put countdown latch after all the logic finishes. So, and we don't need to touch any source code. Yeah, here it is. And in the test, we just like plugs. We just plug it into our test, and then we rerun them and watch them pass without a hitch. So that's a cool thing. And for these, I wasn't able to come up with a really nice name, but with a little slogan, so less time wasted, more test passing. And a good thing about using countdown latches is, first of all, you don't wait for something you don't know how much time it takes. And if something happens, if like your test fail even with using countdown ledge, it doesn't indicate that you didn't find this like magical number. It just indicates that probably something really is wrong with your code. So it's worth looking into it. So yeah, that's 2 little tricks that can help you with testing your multi-threaded code. And you know, with all this journey to Euruko, I actually realized that getting your visa and writing tests for multi-threaded code, they look a lot alike. Because like with getting your visa, you just sit there waiting for an unknown amount of time, just like sleeping, and you're never quite sure if your application will pass or fail. And when it fails, it might be just too late for that. So, and you know, as much as I'd love to patch the embassy code and don't experience this again, unfortunately, we can't do that. But what we can is we can take control of our test and make sure that they behave the way we want them to do. So divide your logic, don't waste your time, sleep well, and thank you.